Hello and welcome to Martin Maths. I'm doing a video for my Year 8s. This week we're looking at Pythagoras in 3D problems and some cubes. This might be a video you might want to watch twice or stop it halfway and then continue it later in the week. So the first topic is 3D trigonometry. So if you imagine maybe you've got a cone and you want to work out what the length of that slant is. You might know its height, and you might know the radius of the base, but you don't know the slant. So trying to visualize this, I found a toy here. It's one of those ball poppers. So it's probably the closest thing I have to a cone. So we might know the height of it, and we might know the radius or the diameter, but imagine that I don't know what that slant is. Imagine a tall building that you might not know. And so you've got to imagine what triangles might you see in that shape. And if you think of that height and that radius and then the slant, that makes a triangle there. So let's say the radius was 3 and the height was 7. Now you've got a right angle triangle, and we now want to find out what that slant, that slope there is there. And so we'll use Pythagoras. 3 squared plus 7 squared is 9 plus 49, and that'll equal hypotenuse squared, and that's 58. So if we're leaving it in radical form, we can have root 58, or if we have a calculator and want to get to 3 single figures or 1 decimal place, we can say the height is 7.62 or thereabouts. Okay, so the idea is to always look for the right angle triangle in shape. You might have another case is a cuboid, and you're asked for the diagonal length across that. So you want to find there'll be a triangle on the floor you need to find, and then a triangle with the height. So that'll be the width and the length, and then this will be the diagonal across the floor there, and the diagonal there. But we'll go through that one in class. Okay, so another topic we want to look at this week is cube roots. So say the cube root of 8. So here, when you write the square root, you don't always write that 2. By convention, that symbol on its own means the square root. But here we're looking for what number times itself 3 times is 8. So 2 times 2 times 2. So it's not 6, so that's 2 times 3. It's 2 times 2, which is 4 times 2, which is 8. Now, unlike square roots where you can't have a square root of a negative number unless you study further maths, so those don't exist in the real world, you can have the cube root of a negative number, because minus 1 times minus 1 is positive 1, but then times minus 1 is minus 1 again. So the cube root of minus 1 is minus 1. So I've written that as though it looks like those are the answers. Just to be sure, 8 is 2 times 2 times 2, and minus 1 is minus 1 times minus 1 times minus 1. Okay, so just watching my brackets there. Okay, and then another thing we want to look at is how you saw, say, the square root of a number is the same as, if I write here, the square root of A over the square root of B is the same as the square root of A over B. Same thing happens with cube roots. So here, let's take the example of the cube root of 64 over 8, which is the same as the cube root of 64 divided by 8 is 8. And we've just seen that that is 2, but we can see that that's the same as the cube root of 64 all over the cube root of 8. Cube root of 64 is 4, cube root of 8 is 2, 4 divided by 2 is 2. Okay. So there we go. That's some ideas of cube roots of negative numbers, this rule that's the same as the square root rule, and some examples there. And just to cover that 2 times 2 times 2 is 8, not that 2 times 2 times 2 is the cube root of 8. Just to be clear on that. We'll go through that in class. Okay, thanks for watching.